Here are the Module 12 Part 1 notes. This is page 5. So, notation again. When do we use X? When we're referring to an individual. And the same with sigma. When I am dealing with just an individual, I am going to use the population standard deviation. When do we use X bar? This is when we're dealing with a sample mean. Right, and that's what we talked about before. That is what X bar means. Same thing with sigma over n. We will use that as our standard deviation or standard error, whatever it's called, when we are dealing with a sample mean. Okay, so nice bold type on how we are going to set this up, and I put it at the very top, but we're not going to use this for 7 and 8. Example 7 says IQ scores are normally distributed with a mean of 100 and a standard deviation of 15 if we draw a random sample of size 9. So we got a random sample of size 9. We want the standard error of the mean. So our standard error again, that is sigma sub x bar. We find that by taking the population standard deviation, divide it by the square root of the sample. There's our square root of the sample. We'll stick that number in there in a minute. We have a standard deviation of 15. So I have 15 divided by the square root of 9. 15 divided by 3, which gives us a standard error of 5. Now think about this. If we're taking random samples, I am using more data points than just one. And so when I find the average of those, I would hope that they would be closer and closer to the mean than an individual data value would be. Okay, so let us do this again. We've got a random sample of size 25 this time. Still have that same standard deviation of 15. So our standard error is sigma sub x bar, and I'm going to write this again. Got 15 divided by the square root of 25. And so I'm going to point that out. Okay. So example 9, now we're going to take a look at these bold directions and make sure we get everything we need. We've got the average height of an American male is 70 inches with a standard deviation of 3 inches. If we take a random sample of 16 men, what's the probability that the mean height is more than 72 inches? So let us start in here with what we have. We have got the population mean is 70 inches. We have the population standard deviation is 3 inches. We have a sample size of 16, and we are checking that the sample mean is more than 72. So here's my population mean. Keep in mind that is also the mean for all samples of size 16. Okay. So let's figure out what our standard error is here. I have the population standard deviation divided by the square root of the sample size. Oops, and 3 over the square root of 16 here. 3/4, 0.75. So in my normal distribution, one standard deviation for a sample of size 16, 70, holy moly, not even sure what I'm adding here. 70.75, 71.5. Okay, so just by looking at this, 72 inches is pretty tall. Here's my third standard deviation, 72.25. I want the probability that in a sample of size 16, my height is greater than 72. So that is going to equal 1 minus. Again, we've said that that sampling distribution is normal. Okay. So even though we've got the smaller sample size, my N is 16, we know that heights of American males are normally distributed. So that smaller sample size is not going to kill us here. So we're looking for an X bar of 72. Our population mean is 70. The standard deviation for a sample of size 16 is 0.75. I want that cumulative, so 1 at the end. I am going to round correctly to 4 places. I get 0.00379, which rounds to 0.0038. Again, you know what? I didn't shade here. Make this 72. I want more than 72. Actually, there's my Excel command. So I'm looking for this little bit. Makes sense that it is a really small percentage. For example 10, we've got the average height of an American male is 70, same one, with a standard deviation of 3 inches. For a random sample of 16 males, again, we know from above that our standard error is 0.75. We want to know what mean height is in the 30th percentile. So we've got the probability to the left is 0.3. There's our 30%. So we're looking for a height. And we're talking about a sample of size 16, so we are looking for a sample mean. We here are going to use norm.inverse. I want a 30% probability. Our population mean is 70. Our sample standard deviation is this 0.75. I get 69.6 inches. So let's see if we can color code here. There's the average height of the American male. We are looking for the 30th percentile. And we've got a random sample of size 16, with a standard deviation of 3. So our sampling error we figured right here. And there's everything.